The right join works as a mirror of the left join. It selects the dataset corresponding to the intersection of the two tables, plus the remaining records from the table position to the right of the join operator. Again, please take a look at the Venn diagram and the SQL syntax. As you can see, the syntax is exactly the same. We will just need to change the operator from left join to right join. And let's run it. Here it is. Let's go to the results. As you might notice, this is exactly the same result we have for the inner join. This is merely a coincidence. This happened because all the values for column borrower ID on the loan table also exist on the table borrower. Therefore, all records from table loan are listed here, and this is what the right join necessarily does. The full join brings all the data from both tables. It is more like extracting the union of the two datasets. The new values might appear on the columns either from the left or from the right tables, or both, depending on the correspondence of the keys on both tables. The Venn diagram for this operator is here. And again, the syntax does not change a bit. You just need to change the operator. Here, we're going to change from operator right join to full join. When we run this, press F5, we'll see a very different result. You see all 8 records from table borrower are here. And again, all 5 records from table loan are listed here. This is what the full join does. Finally, let's talk about the cross join operator. The cross join is something very different from the previous examples. It calculates a Cartesian product of the two tables, that is, combine each record from the first table with every record from the second table. For instance, in this example, table borrower has 8 records and table loan has 5 records. When running the cross join, you will get a data set with 40 records, 8 times 5. Let's see this happening. This time, we will have a slightly different syntax. When we talk about cross join, there's no need to see a combining key. So we exclude this. And here, let's run this cross join. Take a look. Here we have each record from table borrower combined with the same record from table loan. All are D1 here, you see? Then again, we repeat the same process for each record on table borrower for the second value mean second key value on table loan. It goes like this until the end, when we have 40 records in total. Cross joins are seldom used, but self-join. This is not a real SQL operator. This is just to remind you that SQL allows you to join a table with an image of the very same table. When writing the SQL statement, it is mandatory that the table and its image use different aliases. Self-joins are necessary, for instance, when you have a table representing a company's org chart and its hierarchy. This table can have columns such as the employee ID, employee name, job, and the employee's boss ID. In case you want to find the name of somebody's boss, you need to use a self-join. Employee's name comes from the original table, and the boss name comes from the image table. I hope this idea gets clearer with this example. What I'll do here is to create a table called employee, and this table will have the columns I've mentioned before, and run it. Okay, now we have a table. Now I will populate this table with a simple example of a company with only 6 employees, and I'll populate this table with the information for those 6 employees. Okay, before getting the information I've mentioned, let me show you how we have the information on the raw form, let's say. This is how the table stores the data. This is it. The ID, which should never repeat. The employee name. The job title. And here we have the ID of this person's boss. In this case, this employee, Gustavo, is associated to Pierre, the CIO. I can say this by looking at the table, but you know, in a report you have to show things in a better way. So let's run a new example with the self-join. I'd like to show the employee ID, the employee name, the employee job title, and the employee boss ID. Those are the columns we originally have in this table, employee. But I intend to add new information. I will show the boss name getting the information from a mirror table. And I'll also show the boss title, again coming from this mirror table. This is why I used aliases here, just to make sure we understand which name we're talking about, the employees or his boss, and which title, job title, we are talking about. Again, the employee or the boss job title. The self-join will work like this. I will select the table and give it an aliases E, and then I'll select a join operator, a regular join operator, to the very same table as an image. And to make sure this is more understandable, the aliases I picked here is mirror. And the correspondent key on those two tables are this. Get the boss ID from the employee table and make it equal to the employee ID from the mirror table. This will make sure when I get information from the mirror table, I'm sure I'm talking about somebody's boss. And let's run this example. Here we have the results. As I said in my example, the employee Gustavo works under Pierre, who is a CIO. The employee Henrique, an accountant, works under Bharat, who is a CFO, and so on. Again, both chiefs here, Pierre and Bharat, works under Sam, who is the company's CEO. We see we have all the company's hierarchy here, and we have an extra detail. You see Sam, he's no boss because he's the CEO. This record is only shown here because in advance I thought about using a left join in my SQL statement instead of inner join. When I did that, I made sure I would show every single record from the employee table and not only the intersection of both tables. As the CEO had no boss stored here in the table, this single record would be left out of the result set in case I used inner join. Well, I hope this information about self-join got clearer with this example. And let's return.